You move your thumb, that's why.
Bro, what is that?
What's up, Jigger?
What's up?
It was okay. It was okay.
That was not bad. Not too
Yeah.
bad. Not too
How
bad.
you doing?
Pretty good. Pretty good. It's been a little bit of a while, but we're back.
Yeah.
Back for our 2 subscribers. We see you out there watching our videos.
It's episode 14, week 124, if we are not wrong. Maybe 125. But honestly, at this point, it doesn't even matter.
Yeah, 2 subscribers or 2,000. We're here, making it on our way to becoming top 1% podcast. So
How many episodes we have to do more? 7 more to be 21.
no. We need 20 total, I think.
Yeah, so if you do 20 episodes, so
Yeah.
according to statistics, if you do 20 episodes, you'll be in top 1% of the podcasts.
Yeah.
Because most podcasts they will stop after a few episodes, or some goes like 10 episodes and then they never go up to 20 episodes. If you pass the 20 episodes, you'll be in top 1% of the podcasts.
So that's the goal. I mean, we're working our way up there
Slowly.
slowly.
Dude, last couple of weeks, even a couple of days, maybe a couple of years even, the AI race is going crazy.
It kind of went like ridiculous. Like there was lawsuits. There were like companies battling each other out. I mean,
There's new companies are coming. There's getting so much money raised.
yeah.
Like OpenAI, it's worth of 300 billion. They raise the money 300 billion valuation, which is kind of insane. They don't make that much of revenue.
It's the
Not even
potential,
about-
right?
It is about potential of AGI, but how realistic is that?
I don't know. I mean, I think at some point the hype is up so much that it's like when investors look at it, they don't want to be the one who passed up on OpenAI. They don't want to be the one that missed out on it.
Oh, they don't want
Right.
to be the one who missed out on Google or Amazon.
Exactly,
in
right?
2000s.
So it's like, would you be willing to overspend a little just to be sure that if this thing goes crazy and it becomes the future and ubiquitous everywhere, you don't lose out, right?
So you're saying the potential, like upside is like possibly 20x of your money. So that's why people still invest big monies on it.
I think so. Like they see the slim possibility that this thing could be that could go out and run away with it, right? They could be the only player in the game, and if you're not part of it, you missed out, right?
Yeah, so OpenAI just released new 4.5 model, which is colossal. According to them, it's like gigantic. Some people are saying it's like 4 or 5 trillion parameters. Some people are saying 1.8. Actually, I don't have exact numbers, but which is massive. And cost-wise, it costs like 10 times more expensive than the regular 4.0 model. And cloud, Anthropic's Cloud Sonnet, they also released 3.7 version, which is also really good models. So yeah, models are getting better and better, but are we getting to the AGI?
I don't know. I mean, see, that was the thing a lot of people said for many years is that, oh, like you can't keep making the models bigger and bigger. Like bigger is not always going to be better at some point. Like you need to change the architecture. You have to make like massive fundamental changes in the structure of the AI because you're just going to hit a ceiling where like more parameters is not going to be better. But the thing is, even though people kept saying that, like, oh, we're going to hit the ceiling, we're going to hit the ceiling, these companies, they're like, well, let's just try it. Let's throw, 1 trillion parameters, 2 trillion parameters. Like they keep going more and more, and the results are, it still gets better.
It is getting better, but the difference is like the cost to profit is not that big. So
Right.
it's not linear. Like
Yes,
you put like
yes.
so much data, your training cost is gonna increase, but then the output is not linear as you expect. So it's not if you put like 10 times more training parameters, it doesn't mean like your model is gonna be 10 times better.
Right.
So maybe by hitting the ceiling, they meant that at some point the training cost is going to be so much expensive that there's no point of it.
I think it still hasn't reached that point yet, though. Where like, I mean, they're still making these models with, significantly more parameters, and it's costing, like you said, significantly more, but it works. They're better, and people want that. People are paying for it. I mean, if you come out with a huge model, costs you tons of money, but then you get a $300 billion valuation, That sounds pretty good to me.
Yeah, but in comparison, there's like some Chinese models. According to their sources, they only spend $6 million on training them. I don't know if that's true or not, but from your hardware engineering perspective, like, is that true? Do you think, like, how possible is that to train such a big model? It's,
So the controversy with DeepSync, from my understanding, is that they started with OpenAI's model. So OpenAI, they trained from scratch. They created with their own like structure, and then they train their models from scratch, use like scraping all the data themselves. So they pull basically all of the internet,
yeah.
right? They curate it, and then they use that to train their models, and it costs a lot of money doing it from scratch. What DeepSeek did is they started with OpenAI's models that they've published, and then they train on top of those.
I don't think like OpenAI has like open models. Like that's the thing about like maybe they make memes about OpenAI because like it's not really OpenAI. They don't like models are not available. You can use APIs to call the model, but model itself it's not available. So that's why the meme is they should be named closed AI.
Yeah, I don't know like how they got access, or maybe it wasn't OpenAI, maybe it's a different company, but I know they took some pre-established model already, and I know the controversy was that they were saying people were saying like, oh well, you can't just steal the model, right? Like it's like, oh, these people spent so much money developing it, training it, and you're just gonna start with that and then build
Right.
on it. Like you can't steal that. But
I think like the controversy was that they used the OpenAI models to train their models, so they get to
yes,
generate the data. So there's a term called for that when you use another large language model to train another one. So basically, instead of getting all the data themselves, they start asking questions from the ChatGPT and then get
I
the
see.
data.
Yeah, so the question is like, how legitimate is that, right? Is that stealing somebody else's work? And I think
Not guilty until proven.
so. Their response, right, which I think has some validity to it, is that well, OpenAI trained on the entire internet. Did they get permission from everybody who created all that information on the internet to do it? No, they just did it because it's out on the open internet. And they said, well, this company has a model that was trained on public data, so why can't we use that?
Hmm.
Which, I mean, I think there's some truth to that too. But that's part of the reason why they're able to have such low cost.
Yeah, but second reason they're saying like it actually didn't cost them 6 million. They apparently have like 50,000 NVIDIA H100 GPUs.
Yeah, I mean, I think there's some truth to that too. Like, there's no way. That cost is so low. There is some offset somewhere, like maybe they're not including the cost of procuring some hardware or something. Because yeah, you're right. That cost is way too low. They're playing with the numbers somehow.
Yeah, that's what I'm thinking too. So, but that created kind of big um, question in the market. Is like, oh, is Nvidia still relevant? Like, people are gonna buy GPUs from Nvidia to train the models? Because if it costs only 6 million to
Yeah.
train, like, and you don't need that many GPUs.
I think what's happening is so from my understanding, NVIDIA they had a very strong hold over the AI market in the beginning, mainly because of two reasons. One is their GPUs were very good. Like it was just kind of circumstantial that they developed GPU and compute hardware that was used for other things, like in biology they did like protein folding and some other problems, and it was used for that and very effective. But those were niche markets.
Hmm.
So not many people, were interested in those markets. But when AI came, it just happened that this was a very useful tool for AI. And once AI became huge, they already kind of had the lead in that field because they'd been doing it for a while.
Right.
So they had the edge there. And the second thing was when all these companies started developing these AI frameworks like TensorFlow, PyTorch, they were at the forefront of making sure like we have the best APIs, we have the best like software and drivers to help you use NVIDIA hardware. So if you want to use NVIDIA hardware to accelerate your whatever AI model that you're developing, they have all the tools already ready for you and they're very easy to use.
Hmm.
If you try and use like Intel and AMD, they had some other like tools you could use. A lot of bugs, very cumbersome to use. Not a lot of like industry adoptance of those tools. So I think that was a big advantage they had. But over time, I think you're gonna see that there's new players in the game now. Like, I mean, if you look at AWS, they have their, I think it's inferential chips, which are the AI accelerators that they provide at a significantly lower cost.
Actually, on the same topic, like, how is it those NVIDIA chips, which are specific for GPUs, like, I'm sorry, specific for AI training, is different than one like GPUs you have for gaming?
Yeah, so I think it's mainly in the layout of the like compute units in there. So in like very simple terms, in AI, there's one operation called multiply accumulate.
Yes.
That is very important. That's like 90% of what you need to be doing with AI training. And that is one of the compute blocks used for like graphics rendering using your like, graphics card, your computer.
If you have to expand on that, like, can you explain to viewers like what exactly that like multiply operation does?
Yeah, so think about you have like two long lists of numbers and you want to multiply them with each other and then add them all up at the end. That's basically like the core. Like if you break down any AI model when you're training it, that is like the core most basic operation that you need to do. So you need to do it like millions and millions and millions of times,
Right.
right? So a regular graphics card will have some of those compute blocks for multiply accumulate in there, and it works well, but it has a lot of other things related to like calculating different like shapes and geometries and other things for like visual rendering. So basically what they do is they wipe all that stuff out and they take, okay, we want multiply accumulate, we're going to make the whole chip just that, basically. Put a huge memory buffer so we can load tons of data into it all at once and just run it over and over again. And that's pretty much how they make these like tailored chips.
See, and then so that's only the training part.
Yes.
But when it comes to running, how does like that model goes to into your GPU and then gives back as a result?
So it's the same method actually. Like training and inference, the tools you need in the hardware are very similar actually. It still is multiply accumulate, and it still kind of works the same way. What it does is, if you might have heard like these inference models need a lot of memory. So the reason why is they load the whole model onto the memory on that graphics card or the AI chip, and then it will take those pre-known values from the memory as well as whatever like picture or text or whatever you put in, and it'll load that in, and then it does that multiply accumulate with that. So it's mainly just that one operation. It needs to do it a lot of times really, really fast. And I think you're going to see all these new players who are now making these specialized AI chips. They're going to be lower cost and they're going to work just as well, if not better, than what NVIDIA can produce.
Well, this is not financial advice.
No, no, no.
So you saying that like companies like Marvel, Broadcom, AWS, or even like right now, I think Google's building their own
Yeah.
GPU cards and chips. So those are gonna be over time catch up to NVIDIA and then may even surpass because they're gonna be like lower cost.
Yeah, so I think NVIDIA has a leg up on the technology, right? Like their chips are very high performance, but they also know that they're kind of they're the only big player in the game right now. So they charge a really really steep premium for it. Whereas like you're gonna start to see Google Tensor and you have NVIDIA inferential chips, they're gonna or the sorry Amazon inferential chips, they're gonna cost a lot less, and they're not gonna have those massive margins NVIDIA has. I think that over time you're gonna see people are gonna choose to use them, even if maybe the software is not as easy to use as the NVIDIA. They're gonna choose because I mean when you have a massive price difference, why not?
But is it possible that NVIDIA just gonna drop the prices and then
Oh, could be,
like better?
could
Because
be.
one of the arguments I keep hearing that NVIDIA has this drivers called CUDA, like
Yes.
entire like architecture like built specifically for training AI models, and also on top of that, they said like to connect the multiple GPUs, they provide networking tools and networking hardware, which is
Yes.
like better than anyone else. So that's another reason why people keep choosing NVIDIA. But are those actually good?
Yeah, I think so. From my experience, it is much better. Like I have tried to use AMD based like acceleration for
Mm-hmm.
AI models, and installing the drivers, getting them to work, the APIs, it's very difficult to use. Like it's the problem is all the different software you use, like whether you're using PyTorch or Cafe or like TensorFlow, it doesn't really work well with it's not built for like the AMD APIs and drivers. But with NVIDIA, it's just like
It works.
yeah, like you just install the package and
And it
everything just
works.
loads and it just works. It's like all integrated in there. It's abstracted from you. But I think over time what's happening is you're seeing less and less people buying their own GPUs, creating their own training server farms. And when you look at a company like, let's look at AWS, right? If they're doing all the networking and everything for you, right?
You
Like
just rent it.
exactly. So in the data center, maybe it is more of a pain in the butt to like, okay, I gotta set up the server and like have all the networking communicate and load the model over multiple devices and multiple hardware. But if they figure all that infrastructure software out and they just tell you, you upload your model to AWS and you hit train, what do you care, right?
So what you're saying is like in the future, instead of those like even like smaller companies, instead of building their own data centers, they will just rent the compute units from the big players like Google Cloud or AWS or Amazon, Microsoft Azure. So
Yeah.
and then they will just like as you said, hit the button, train, use as much as they need instead of building it. Connecting all the GPUs themselves and building their farms.
Yeah.
They will just use the cloud ones. So in that case, like Amazon's gonna use their own chips, and
Yes.
then Google's gonna use their own chips. So over time, Nvidia might lose their share.
I think so. Like, I mean, people have been doing that for a long time, you know? Like, I think people building their own server farms have kind of been out for a while. But the big advantage, I think, is like, if you look at it from AWS perspective, before their customers demanded performance. So, really, your only option was at the time NVIDIA, and you have to set it up yourself. And if you try to use anything else, you're gonna have to incur the extra cost of okay, well this like software is very hard to use and networking tools are not good. Like you have to deal with that when you set up your data center. But if you create your own chips and you can custom design everything to work for your data center environment, now you can make it all work together. Now you don't have to worry about like, well, uh, this is like going to cost me more to set up, or it doesn't
Mm-hmm.
matter. You're recouping all that cost because you're not giving all your money to NVIDIA to buy their hardware. It's your hardware.
Right.
So I think what they needed hardware that could meet the requirements and performance of the customers. Once they were able to achieve that, they're like, well, we don't need NVIDIA anymore. We can do it ourselves.
So going back to the like AI models, the one thing is to train, but then another thing is like we still need the GPU to run them.
Yes.
So is the demand for the GPUs are gonna slowly die down over time, or do you envision like the demand is gonna be still high for them?
So I think right now it's a bit of a confusing market because we always refer to them as GPUs, but in reality, the new like if you look at I think it's like a NVIDIA A100 or something, right? Those are not really GPUs. Those are not really graphical processing units, right? They're AI accelerator cards. Like that's what they're designed for now. And really, if you look at the anything that anyone is doing, Tensor, Inferentia by Amazon, it's all AI accelerator. I think AI accelerator is here to stay. Those will be here, and we will need them to train and run all of our AI tasks. But I think what you're going to see is you're going to see is like the die down for commonplace multi-purpose GPU cards. Things that can do graphical processing as well as AI, and you're going to see more of a focus on AI specific cards. These are tools designed specifically for AI, and it's going to be, I think, less of the kind of thing that you have on a small scale at your home. It's just going to be more stuff that's like enterprise grade, designed to just sit in a data center and nobody else has it. Like one-off custom designs. And it's just everything will be cloud. You want it, you just rent it from the cloud. That's it. You don't need to buy it yourself.
That's right. Yeah, it's gonna be becomes like similar to regular CPUs. Now, if you
Yeah.
want to host a website, you don't have to like build your own server.
Yeah.
Most likely, you'll
Yep.
just like go to big players and then rent the cloud and just host your websites.
Yeah, I think it's the exact same way. Like there's no real reason for you to have your own stuff anymore. It's much more scalable. Usually, like when you do scale, the cost is significantly less. The uptime is way better. So
So GPU architectures, so CPU architectures, like there's two main ones, like ARM and then x86. So what about like the GPU architectures? Is there like standardized architecture for this, or is it open source, or someone has a monopoly on this?
so you mentioned CUDA before, right?
Yes.
So CUDA is the like API interface that is used for interfacing with NVIDIA cards, right? And similarly, AMD has Vulkan, which is like their way of doing it. Um, And the truth is, when it comes to if graphical tasks, they're very different. Like the way that I mean, the core principles are the same. The same thing with like x86 and ARM, right? They will both have similar compute units like in the CPU. The structure will be roughly the same, but the way that they process and the size of some compute units and like, the way they're arranged might be slightly different. So think of it like, okay, you have a car. They all have an engine. They all have wheels and tires and steering wheel, right? But maybe like the specific components and the way they're arranged are like slightly different, right? It's kind of like
But
that.
there's like argument like one could be better than another. Like for example, in the comparison of the x86 to ARM, ARM's like more efficient, use less energy, and the size wise is also smaller. It's like
Right.
compact. So that's why MacBooks they also switch to ARM based chips, M1, M2, M3. So similar to GPUs, is there like one architecture of the GPUs better than other,
There
like
is
more
a
efficient? Because the GPU is also like another thing about GPUs, like efficiency is like matters. How much energy consumption also matters. So when it comes to that, is there like one player better than another?
Yeah, I think there definitely is. So in the graphical side of things, which translates a little bit to the AI accelerator, but not completely, NVIDIA has been like the leader by large in efficiency and performance. So if you're talking about we just want for one silicon die of certain size, certain billion transistors, what's the maximum performance we can get and lowest power consumption, NVIDIA will be the top every time. Their architecture is designed for that. Whereas AMD, they mainly go for, well, at the same cost, we can give you more compute at lower efficiency, so it'll consume more power, but you'll still get the performance because we just have more compute on there. It's low. Each core may be lower performance, but and use a little bit more heat, but we have more of them, so it makes up for it. So it's kind of like a different strategy to getting the performance at a cost to the customer. And a little bit of that falls in AI too. NVIDIA AI accelerator cards are very efficient. But AI is a little bit of like an open field right now because it depends on how closely you've designed your model to run on specific hardware. So let's say I know I'm going to be using NVIDIA card. I can design my model within the constraints and within the like structure of NVIDIA accelerator cards to make sure it runs really well on them. And it may not run as well on Tensor or like Inferentia, but I could also do the same for those too. So it's kind of like it's a little bit hard to differentiate right now, like who is got the most efficiency, who's the best, because models right now, typically you will kind of know who you're going to go with. You'll decide like, oh, I'm going to train on AWS and Frencha. Then you look at how they're designed and you look at their APIs and you kind of design your model and software to work well with it. So
Makes sense.
yeah.
Yeah, it's kind of interesting that how we in 60 years how we moved from like big gigantic transistor to those GPUs and AI specific GPUs, and
Oh
we can
yeah.
like do so much more stuff. It's kind of crazy. It's just 60 years.
I think even you look at, I mean, just what, like 20 years ago, there's basically only two types of processing chips that anyone used for compute. They used CPUs for general purpose like software, and then they used GPUs for like graphical applications, and that's it.
Yeah.
Nothing else existed. And now we have like, okay, we're gonna have AI specific chips. We're gonna have like, all these different types of hardware for specific applications. I think that's what makes it really exciting, from the hardware perspective, at least.
Yeah, but the structure of the chips, in like whether it's a CPU or it's a GPU, just like mind blowing. Like I saw the video where just like they put the microscope and then they show you
Oh
like
yeah.
the insides of the chips, and it's like tiny pieces, and you'll be like, wow, I didn't know that.
Yeah,
It's so
it's
crazy.
it's pretty crazy how they're able to pack all the transistors in there and make
How
all
do
the
you do
connections.
that?
It's
It's
so
like how's the technology like evolved that? Like it's a nanotechnology, right?
oh, right.
Why we able to do this kind of stuff, but then in other, um, like in medicine, we won't be able to do similar things.
So I think a lot of it comes down to the materials and the amount of time and development that's gone into it and the money involved. So from early on, people realized the value of having compute and how much like money it could make you as a business. Like if you produce better compute and better chips, that has a huge impact on world technology, and people will be shelling out billions of dollars for that. So I think that drove these gigantic fabs, which are, if you didn't know, the facilities that build these state of the art chips are the most expensive factories in the world by far. And
How much it costs like to build one?
oh, I
Especially
think
since
I
like
think
we
they
have a
estimated like $1 trillion or something like ridiculous. It was like insane.
so if you want to build like because of tariffs, if you want to build a semiconductor factory somewhere in Arkansas, how much
Oh,
is it gonna cost to build?
realistically, infinite. You cannot do it because the knowledge and the people you need to do it are so highly specialized that you just won't be able to get them. But it would be probably trillions. Like it's ridiculous how much money it costs to build these things. Like
Intel has factories in the United States.
they do, but so the players in the game right now, they have those specialists and they have the people who know how to set it up and do it. But if you're a new player now, it's basically impossible. Like so I'll give you an example. Like TSMC is the world leader in microchip production. They're building a facility in Arizona. So someone I know, they told me their sister just got a job working for TSMC in Arizona. And they said their security is so tight. They have no wireless internet on site. They're not allowed to have their phones at all while they work. Like this is an extremely high security facility because their secrets, they know how valuable they are. That if somebody was able to poach their, engineers, their designs, their, fabrication techniques, it could cost them billions.
So do you think it should be classified equally as space programs? Because like for example, for space programs, if you're not United States resident or United States citizen, you're not allowed to work for those companies. Or any like defense contractors, you're not allowed to work unless you are U.S. citizen or a resident. So do you think like for those high tech items like semiconductors, they should be classified at similar level?
So at least what they do currently, from my understanding, is like all those TSMC like production facilities, they're producing customer consumer chips. If you want like military stuff, like the chip that's gonna go into some military application, military satellite, or like military guidance in a fighter jet or something, those are not produced there. The military has, like, U.S. government has their own small fabrication facilities that are like highly top secret, that are made to produce just chips for the like U.S. military, U.S. government purposes. So those are highly secure, and those, like you said, you have to like have security clearance and everything in order to
Well,
work
since
there.
we have that, like, why is it so hard to reproduce similar facilities for other industries?
So it's like TSMC has been doing this for so long. Like they have technology that is
United States has the best scientists in the world, so
it.
how difficult it could be to reproduce that? How difficult it could be to build a facility? I know it's extremely difficult, but
But
at the same time,
I think it's
US has
just.
the best researchers and scientists.
I think the problem is like these companies have done such a good job at locking down the people. So it's not only the best researchers, right? Like it's how much time have they been spending working on this problem? TSMC has had decades. They've had these like some top minds working on this, developing it for like multiple decades. So how do you catch up to that? Like,
I'm surprised like no one else like tried to reproduce their success.
oh, they
We've
did.
seen like OTMs, they're like building those facilities and they're getting so good, but then others didn't try to copy or
They
invest money.
did. They
They
definitely
did.
did. So at times Samsung tried to compete. They wanted to offer similar production. They were trying to say like, okay, we're gonna ramp up, and then within like 4 to 5 years, we're gonna offer similar production capabilities to TSMC, and they couldn't do it.
You're talking about Exynos chips, which they built on their own.
I mean that, and then they're just a fab facility, right? Like the size of the transistors and like the output they're able to produce. They wanted to match TSMC spec, and after a few couple years, they said they're so far ahead we can't, and they gave up. They said, and they made a statement saying we're no longer going to compete with them because
So
we can't.
TSMC, they also make the chips for Apple, right?
Yes,
So why Apple doesn't build their own facility?
because of how difficult it is. Like it's nobody has been able to do it, and people have tried. So we're talking like Samsung, a company that has some of the best fabs in the world. Like
So you're saying like the entire world is just there's a bottleneck for the entire world
yes,
is one company.
yes.
If something happens to that company, if the knowledge gets lost, if there's someone nukes like let's say someone nukes their like headquarter, so the world's gonna
We will be about at least 4 to 5 years back in terms of technology of state of the art performance compute. Yes,
that's crazy.
it is. It is, and I think that's why people got really scared. Is they're like this one company is the bottleneck, and when they had production issues during COVID, like we all saw the impact of that. We saw how consumer electronics and all the products, technology that we buy, how it was all impacted. And people were scared. People realized that, wow, if this one company goes down, that's huge. Like, that's everything.
Yeah, I still don't buy that. Other companies cannot build it.
And bro, you go do it. Startup.
Yeah, 100 billion. Give me 100 billion.
Give you $100 billion, set it up. Arkansas.
Arkansas? Alright, sure, yeah. Let me talk to Trump. You're talking about technologies, and then every time I talk to someone from China, I ask them about the Chinese EVs, and even people who try Chinese EVs who are not from China, they all praise them.
Yeah, I
They
mean,
all say that it's a superior, it's cheaper, and better than like any other EV cars.
they're like, what's the big? Is it BYD? Is that the big one?
They
Or
have BYD, they
yeah,
have Li, they have like Nino.
I think. Okay, first thing is I look at the pictures. They look good.
Yeah.
Like I think whoever's designing these things, they're doing a good job. I think all of them look good.
Even Xiaomi has the cars now, which kind of looks like a Model S. But
Some of them are kind of like you could tell it's a little bit copied, but like I think they still look good. Like these
yeah.
cars look good, and the specs they're promising, good range,
Fast
charging, like, and the cost is so low.
So one of my friend who I play soccer with, he was saying that in China you can buy EV for 10,000.
Yeah, so it's making you wonder, like,
I have a question. Like one thing is like yeah, manufacturing cost is cheaper in like China, but then the same car would cost in the United States like 30K.
Yeah,
3 times more.
yeah. I mean, manufacturing cost is one thing.
It's still gonna be manufactured in China, most likely.
I mean, that's true, but I mean, you don't have to ship it across
Yeah, it's
the
so
ocean.
expensive to ship.
They're pretty expensive. It's a heavy car. I mean, they cost some
It's
money.
like $1,000 per car. Plus logistics, like other
Yeah, yeah.
customs, so like another 9K, so 10K over.
I mean, I also think the development cost is a lot less there than it is here. That's another thing. So it's not
You're
only
still
manufacturing.
you still manufacture it in China.
Yeah, but like, okay, to hire engineers here to design a car versus hiring engineers in China to design a car. I mean, it's a lot cheaper to design engineers and design a car in China than it is here. I think that's a major part of it, right? Because part of the cost of your car is also they have to figure out how much it costs them to develop it, and then like make sure that they're gonna get paid more than that if they sell X amount of cars. So in China, you can design the car a little bit cheaper. Mechanical engineer and electrical engineer in China costs a little bit less than it does here. So
But is that the main reason though?
I think also, okay, I have heard that the Chinese government is heavily subsidizing EV cars.
It's like tax benefits.
Yeah, so I don't know how much of that comes into play, but I have heard that the Chinese government is like pushing EVs very strongly, and they're incentivizing these companies to produce low cost EVs. So maybe that could be a factor too. I mean, but the bottom line for a customer, $10,000.
Yeah, so let's say you are someone on the lower end of the income, but you can still afford a car. You can still afford EV car
Yeah.
and save on money on gas.
I mean, if you're somebody, let's say you live in a city, right? So like maybe you don't need a car to get around. You can do public transport, but sometimes people like to have a car. You can go different places, drive out, go on road trips, things. But mostly you're just driving in the city a little bit. But you're like, oh, I'm not gonna buy a car; it's too expensive. But maybe you're like, at $10,000, maybe I can afford an EV, right?
Maybe like if you buy even like for 30,000, bro, the cars are nice. It comes like with all the features. It comes
That's the
with, like,
thing.
you're buying a new car. It has heated seats. It has like a heated steering wheel.
I saw
It has a
the
massage. Bro,
yeah,
it
I
has,
saw
like, all
the
the features.
I saw the minivan. It looked sick. The
I know.
minivan looked amazing, and they had like recliner chairs and massage and heated seats and like TVs, huge TV screens. and,
Cameras
like,
everywhere.
I was
yeah.
like, this is amazing. I don't even think you could buy that in America. Like, even I don't even think anything similar even exists.
Yeah, and the price is so cheap for that.
Oh,
Like,
yeah,
you have like
yeah.
all the features, like the premium features, and then
I mean,
you're paying only
Do you?
35,000.
But do you think it's gonna break in 2 years? Do you think that we're gonna push the button and it's gonna break, or like plastic piece gonna fall off, or I don't know about the quality. I have never seen them. Right? Maybe it's okay because maybe it's okay, but I don't
Usually
know.
like long term.
I don't know. I don't know. There's just something I wonder.
Well,
Like,
people complain about the Tesla build quality.
oh, that's true too. Tesla build quality is not good. So,
People complain about McLaren build quality.
I mean, yeah, but that sample size is too small. I mean, they hand build their cars. If your car is not built right, you could probably call them up and they'll tell you the name of the guy who messed up. So, but yeah, I don't know. That's
So do you
it's
think like,
I don't know if they. I think it'll be a long time if they ever come to the U.S.
well,
The
there's
tariffs and
100%
everything.
customs, like
Yeah.
there's 100% tariffs.
But in other countries, like all over Central and South America, even not the EVs, but just Chinese cars in general, they've become extremely common.
When you were in Europe, did you see a lot of Chinese cars?
So many Chinese cars everywhere. They're very common. I think people are really adopting Chinese cars because the cost, you can't beat the cost.
Yeah,
They're just so cheap.
cheap, and then you're getting basically all the features the same.
Yeah, I mean, same kind of thing, similar kind of thing happened in India a few years back. There's a large Indian car manufacturer called Tata, and they came out with a small car that was extremely bare bones car. Like it had almost no features. I don't even think it had AC or anything, but the cost was so low. I think it was like $8,000 or something, or like $5,000, something crazy low cost. But the idea was there's a lot of people there who they can't afford the car, so they buy a motorcycle, but they'll like be a family of four, and they all sit on the motorcycle, and it's very dangerous to like ride around like that with your family. You know, like you have no walls, no protection. So if you offer somebody for slightly more, you can now get a car that has like doors and a roof and a little bit more protection. People will actually really want it.
Also, I
Right.
respect that.
Yeah.
It's basically allowing anyone to afford a car. It's like very similar to how the phones used to be. Like,
Yeah,
remember
yeah.
smartphones used to
Yeah.
be so expensive, but then over time there's like cheaper options, so anyone can afford smartphones.
Yeah, I think in America we don't really like see them advertised much because they're not as popular. But like Samsung has the A line, like I think it's like A51
Yeah.
or A, right? So those are really, really low cost Android smartphones. And I mean, most major companies offer them, like LG and, even all the Chinese companies like Xiaomi and all. They have very low cost options, which are very popular in these developing countries that a lot of people can't afford these expensive phones. But I like that at least now they have an option to have internet access, like, and be able to use social media. Like, it's enhancing your life a little bit.
Yeah, same thing with car now. You can move around.
Yeah.
It's like you can afford this. Talking about